But in general, we can talk about quadratic surfaces, and we generalize it the following. Okay, the general form is given by the following, and this is a long equation. So we have coefficient A, B, C. You can see that I used uppercase. Those are the coefficients of x squared, y squared, and z squared. And then we have the cross product, not cross product the way we define vectors, but cross variables. We have the x, y, y, z, and zx variable product, and with coefficient d for x, y, e for y, z, and f for zx. And then we have coefficients for individual variables, x, y, and z. So plus dot 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 plus, after f comes what? G times x, h times y, and I times z. And finally, we can expect a free coefficient, and everything equal to 0. This is the most general form of a quadratic surface. Okay? The terms x, y, y, z, zx are the result of tilt or rotation of the quadratic surface. We can simplify. Actually, let's write a comment where a, b, dot 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 j are real coefficient. Okay, we simplify this equation by making rotation and translation to get rid of the mixed variable terms x, y, y, z, and zx, and we have a simplified version. And the simplified version is given by two standard form. Remember, whenever we say standard, we usually mean put everything on one side and 0 on the other side. So we have two standard forms. One, only the x squared, y squared, z squared, and the j survive. And of course we can write it as ax squared plus by squared plus cz squared equals negative j. And the other is ax squared plus by squared plus z. In other words, z is not quadratic, z is linear, equals 0. We have one of these two forms. You'll see it in a little bit later. I'll give you a handout that give you basic quadratic surfaces. But I'll give you first one. I think I have time to give you either one or two. I'll try to give you two, and then the rest we'll do on the handout. So here's example 3. Okay. Use traces. In both examples, we'll use traces to sketch a the surface. And this surface is given by we have x squared plus y squared over 9 plus z squared over 4 equals 1. And this is somewhat similar to Ryan's example, except Ryan went even heavier than this one, or about the same thing. And how we identify these surfaces, the easiest thing is to see what happens if we let one variable goes to 0. For instance, if we look at the z equals 0, okay, let me put my finger here. So what you see is x squared plus y squared over 9 equals 1. This is a conic section. What conic section is this one? It's an ellipse. Now, likewise, if y equals 0, we have an ellipse, and if x equals 0, we have an ellipse. So we have ellipses all around. Okay? So instead of setting z equals 0 or x equals 0, y equals 0, the general case is z equals some constant k, right? And we'll have a plane parallel to the xy plane, and we'll have an ellipse, a trace that is an ellipse on this plane. You see that? All right, so this is what we're going to do. We're going to set z equal k, okay? So what do we have? If z equal k, then we have x squared plus y squared over 9 equals 1. If z equal k, then 1 minus k squared over 4. Okay? This is an ellipse, and this is some constant. Now, in order to this to work, the expression y minus k squared plus 4 has to be greater than 0. Because we have a square plus square has to be positive. Okay? If it's 0, then it means the only way this can be 0 that if x and y equals 0. And of course, that's the origin. So we're going to say that this has to be positive, and therefore k squared has to be, for this to be positive, k squared has to be less than 4, or k is a value between -2 and +2. So this gives you the trace. So we have the trace. The traces will be simply the ellipse, the family of ellipses. So the ellipse is x squared plus y squared over 9 equals 1 minus k squared over 4. K is greater than -2 and less than 2. Together. All right. Now likewise, we're going to set up y equals k gives you the following. If y equals k, you have x squared plus z squared over 4 less than 1 minus y squared over 9, k squared over 9 with k greater than -3 and less than 3, and we have z x equal k give you y squared over 9 plus z squared over 4 equals 1 minus k squared, and k is simply greater than -1 and less than +1. So you have these three families of ellipses, and now we are ready to sketch. So to sketch this, I'm going to just sketch 3 ellipses here instead of a bunch of them. Let's start with the ellipse on the xy plane, where z equals k. Okay? So, notice that the boundaries on the xy plane is the I'm thinking about if I did it right. When z equal to k, then k will go from -2 to 2, and y, we have this ellipse, x squared over 1 and y squared over 9. So the ellipse, the long axis of the ellipse is 2 times 3. We go from -3 to +3, and the short axis will go from -1 to +1. So we'll have this ellipse. Okay, so this is the ellipse, x squared plus y squared over 9 equals something, 1 minus k squared over 4. Actually, this exactly will be when k equals 0, because we are setting up at z equals 0. So it simply equals 1. This point is y equals 3, and this point is y equals -3. This point is x equals 1, and in the back we have x equals -1, like so. So this is one ellipse. The other ellipse, the second ellipse, is this one on the zx plane. Okay, so again, x goes from -1 to 1, no wonder, and z will go from -2 to 2. -2 to 2. This is k is -3 to 3, but z, that's what threw me off at the beginning. But you look at the long axis of the ellipse, so -2 to 2, so it's going to be like this. If this is -2 and this is +2, and the ellipse is going to look like so. And finally, here, y goes from -3 to 3, and z goes from -2 to 2, and this is the ellipse. A watermelon or a zeppelin. If you look at the, if you think about the traces, I'm sorry. If you look at the ruling, the ruling is like the scale tone, the scale tone of a zeppelin. Zeppelin. Yeah, if you remember that horrible images of the Hindenburg. So, this one is y squared over 9 plus z squared over 4 equals 1. And this one is x squared plus z squared over 4 equals 1. Okay. Now, of course, you may have more traces right here. Okay.